and so welcome back to this is day 5 of Algebra 2. So I'm going to put some problems on that we did yesterday, so I'm going to try to work these. So take a minute and try to work these. If you need some help, grab your friend and kind of go through these two. So one, I want to find the standard form of a quadratic function, and then I want to determine the axis of symmetry, the vertex, the maximum endpoint, and graph this quadratic. Okay, so the standard form of a quadratic function is f of x is equal to ax squared plus bx plus a c. So that is my standard form of a quadratic, okay? The axis of symmetry here, remember, is negative b over 2a. So negative b, so it's going to be a negative 8 all over 2 times your 2. So the axis of symmetry is going to be at a negative 2. Okay? The vertex now you're going to plug. So that's your axis of symmetry. The vertex is you're going to plug in that axis of symmetry in your function. Okay, so negative 2 squared is going to give me a 4. 4 times 2 gives me an 8. 8 times a negative 2 is a negative 16 plus a 2. So what is that? So that's going to be a negative 6. So the vertex is going to be at negative 2, negative 6. Okay? Alright, so is it a maximum or is it a minimum point? Okay, so A there is going to be Okay, let's try again. So A right there is going to be a positive 2. So what does that mean? It's a positive 2, and so it's going to be opening up, right? So the graph of it will be opening up. So that means I'm going to have a minimum point, right? Okay. All right, so now I want to graph. So I'm going to choose some x values and I'm going to choose some y values. But to choose my x values, I'm going to start where? At negative 2 in the middle. And then I'm going to move up to the left and to the right. Okay. All right, so if I plug a negative 3 in there, negative 3 squared, so what's that going to give me? A negative 4. If I plug a negative 4 in there, so that's a negative 4 squared times 2 plus an 8 times a negative 4 plus a 2, so it's going to give me a positive 2. If I plug a negative 5 in there, so negative 5 squared is going to be a positive 25 times 2, so that'll be a 50. So 50 minus your 40 plus a 2, so that's going to give me a positive 12. So it's going to be symmetric, right? So these values are also, because I'm increasing at the same rate, so these values are also going to be the same numbers. Okay, so to graph this, I'm going to plot my vertex. I'm going to just do that one first. This one is your vertex, right? Okay, so negative 2, 1, 2, down 1, 2, 3, 4, 5, 6. Okay, then at negative 3, you're going to be at negative 4, so 1, 2, 3, 4. At negative 4, you're going to be at a positive 2, 1, 2. And I can't get, there's no 12 there. Okay, and then at negative 1, you're going to be at negative 4. And at 0, you're going to be at a 2. So this is going to be a U-shaped graph there. Okay, so standard form, I feel pretty confident that you can understand what standard form is and how it is graphed. Okay, so vertex form is just a different form that a quadratic is going to be in. It's a little bit easier to see. It's not going to be normal. You're not really going to see this one in vertex form a lot. So the next day that we do this, we're actually going to be going from standard form into quadratic form. So standard form into vertex form. I said quadratic form, but into quadratic. All right, so the vertex form of a quadratic function is going to be, f of x is going to be equal to a times x minus h squared plus a k. Okay, so here, this is very similar to the absolute value. Well, remember when we looked at the absolute value and looked at the shifts and everything? Well, the vertex is going to be the opposite of this, so it's going to be h comma k here. So h comma k will be the vertex. So when you're looking at a vertex form of a quadratic, you can just pull out that vertex. When you're looking at a standard equation, standard quadratic form there, you actually have to find it by looking at your axis of symmetry. So this h right here is actually going to be your axis of symmetry. Okay, so that h right there is going to be your axis of symmetry. See, it's a little bit easier, but the form, you just don't see that regularly. It's just not normal for you to look at a quadratic in vertex form. Okay? All right. Then the A on the outside determines how big, how small, and if it's opening up or if it's opening down. Okay, so this A right here is determines just the same way if determines if parabola opens up or down, and the same rules apply there. If it's positive, it's going to open up. If it's negative, it's going to open down. Okay, and it determines the width. Okay, so if you look at this, what is the parent function of a quadratic? Okay, the parent function of a quadratic is x squared, right? Okay, so your parent function of a quadratic, I should say that right there, of a quadratic is x squared, right? So the same rules apply if we're shifting up, shifting left, shifting right, shifting down. Okay, so same rules apply as when we were talking about the shifts the other day, last week. Okay, so let's look here. I want to determine the shifts from my parent function. Okay, So x squared minus 2, this is going to shift what? Shift down 2. You can only determine the shifts when your function is given in vertex form. I should say that. Okay, so let's look at this one here. Okay, so this is in vertex form, so I can determine my shifts here. So what's going to happen? So this means I'm going to shift down 1, and this negative inside here means I am going to the right, the opposite direction, remember, right 4. Okay. Okay. This negative 2 on the outside means I'm going to open what? I'm going to reflect, so I'm going to be opening down. So I'm going to reflect across the x-axis. Okay, I'm going to stretch by 2, so I'm stretching my u out. So stretch by 2, and I'm going to move to the left 4, because that plus 4 means I'm going to move to the left 4 units. Okay, so the parent function of a quadratic is x squared. So you can determine shifts when the quadratic is in vertex form. You can't look at shifts when it's in standard form, okay? So just know that you only can determine how it shifts if it's in what? Vertex form, okay? So only be able to determine shifts when it's in vertex form, okay? All right. So let's look at graphing some that are in vertex form. So the same rules apply, is I need to find my vertex first, okay? So find axis of symmetry and vertex. Okay, and then you're going to move, put that one in the middle, right? Put on the middle of the table. Go up and down with x values. Then graph. Okay, so if I wanted to graph this function here, okay, my axis of symmetry is going to be at the, it's in vertex form, right? So the axis of symmetry here is going to be a positive 2. Remember, it's the opposite of what's inside. So opposite sign, right? Okay. So the vertex part of it will be what? Oops, sorry. Will be 2, 3. See, I don't even have to solve anything. I can just plug that in, right? And really, how you're doing that is you're setting this equal to 0, right? So x minus 2 equals 0 is a positive 2. So that's how you get it. Okay. All right, so on your table, you are going to have 2, 3 there. And then you're going to move both the left and the right. Okay, so when you plug a 1 in there, 1 minus 2 is a negative 1 squared, gives you a positive 4. Plug in a 0, negative 2 squared gives you a 4, 4 plus a 3 gives you a 7. Negative 1, that's a negative 3 squared, gives you a 9, 12. So it's going to be symmetric, right? So now these values will be 4, 7, and 12. Okay, so my vertex is 2, 3. So 1, 2, up, 1, 2, 3. And then what? 1, 4, 0, 7. 1, 2, 3, 4, 5, 6, 7. Can't get that one on there. And then 3, you're going to be at 4. And then at 4, you're going to be at 7. So look at the parent function. So remember what the parent function is for a quadratic? A parent function is that it's going to go through here. Okay, so here is my parent function. Okay, so this function shifted, the parent function shifted to the right 1, 2, right, and up 1, 2, 3. So my vertex shifted to the right 2 and up 3. So looking at this, right, so your vertex would shift to the right 2 and then up 3, right? So that's the reason we talk about shifts, is so that you can see how it moves left, right, up, and down. Good deal? Okay, so I'm trying to finish that homework because tomorrow we are going to talk about graphing quadratics, or looking at quadratics from putting them in from standard form to vertex form. So you really need to know the differences between those two. Okay? All right, y'all have a good day.